In this video, we're going to find probabilities using the standard normal distribution in 5.1. So this is going to be just like when we found area under the normal curve with the Z table a couple videos ago. But there are going to be some technology problems later that we're going to show you how to do some things with the calculator as promised in that earlier video. So main thing to know here is that the area under the curve is going to be the probability of that event occurring. So the probability that Z is less than negative 1.61, we're going to look up the area under the curve here. Negative 1.61 is 0.0537. 0.0537. And then we have to the right of negative 0.065. So this is going to be 1.0000 minus, and then 0.69875, 2578. 2578. Let's borrow here. And 10 minus 8 is 2. 9 minus 7 is 2. 9 minus 5 is 4. 9 minus 2 is 7. I have 0.7422. Let's say this is the probability that Z is less than 1.57 minus the probability that Z is less than negative 1.57. Already on the table for negative 1.57, 987, 0.0582, and positive 1.57. 987.9418. So I prefer to subtract up and down most of the time. 8 minus 2 is 6. Borrow here. 11 minus 8 is 3. Borrow here. 13 minus 5 is 8, and that's an 8. So we have 0.8836. Now we want the probability that Z is less than 1.96 minus the probability that Z is less than 0. We know this is 50%. So 1.96, 9876, 0.9750. And I can do this one in my head without stacking. There we go. And probability that Z is less than 0.74, 0.701234, 0.7704. And now we're into one of the technology problems. So let me pull up the calculator here. And we want second distribution. Normal CDF. We're not going to use normal PDF at all unless we actually want to draw the normal curve. We're always going to be using normal CDF. If you have a TI-84 Plus that is second generation or more, you're going to get a menu like this that asks you to give the bounds lower and upper, then the mean, then the standard deviation, and it's going to paste it for you. If you have an earlier calculator like a TI-83 or one of the first TI-84s, this is the order that you're going to have to put the parameters into your normal CDF function, and you'll see what it looks like once I paste it. So we want greater than negative 0.308. So negative 0.308 is my lower bound. My upper bound needs to be something super big. And I just like to use 1 times 10 to the 99th power. That's always sufficiently large. It's a z calculation here. So the mean is 0 and the standard deviation is 1 for my standard normal distribution. So I'm going to paste that in here. You're going to see that it says normal CDF is the command, and then it gives the lower bound, upper bound, mean, and standard deviation. I'm going to calculate that, and then it wants me to round to 4 decimal places, just like I would get my z table. So 0.62, and then we're going to have to round here. This 9 is going to round up to a 10, so this is going to be 1, 0, because that 5th place there is a 5. That rounds this 9 up to a 10, so that's 0.6210. Only use the calculator when it has a dash T like this. Otherwise, if it gives you the Z table, assume that it wants you to use this Z table to answer the problem, because you're going to get some variation in your answer if you round and use the Z table when you're supposed to use the calculator, or you're going to get a more exact answer sometimes than the table from your calculator, and your answer will be off, and you don't want that. So we're back to Z tables for this problem. So 1.19, 1.19, 0.8830, but it's greater than, so we're going to have to do 1 minus this, 0 minus 0, 0. I'm going to subtract here, 9, 9, 1. That's 7, 1, and 1. That makes sense to me. So 0.1170. Now we're between 0 and negative 1.80. So to the right, we know is 50%. On the right-hand side, let's look up our negative table here, negative 0.8, and then 1 is 0.2090. We're going to subtract, and we get 0.2910. Okay, this is going to be another technology. Well, no, they're using the table here. I'll compare it with technology for you since it gives 3 decimal places, but they want you to use the table and round here since they gave you the table. So 0.655, they want you to go halfway between the value for 0.65 and 0.66. So 0.6 and then 5 is 0.7422. We're going to be averaging this with 6 is 0.7454. So this is 6, 7, 8, 14. That is 7, 4, 3, 8 as my approximation. Let's see how good that approximation is with the calculator. Second, distribution, normal, CDF. We're going to have this, though, excuse me, 0.7438 is the number that's on the right. We need to subtract 50% from that, 0.2438. There we go. Normal CDF, let's use a lower limit of 0, an upper limit of 0.655, and we're still Z values, so we have a mean of 0 and a standard deviation of 1. And 2438 is right on the money. When we round to 4 decimal places, you'll see that it was actually a little smaller than that, but it's within the margin of error when we round to 4 decimal places. So this is one of the techniques that we use when we get a number that's in between two numbers that are on the Z table, is that if it's closer to the smaller number, we'll use the smaller number. If it's closer to the bigger number, we'll use the bigger number. If it's somewhere right in between, like a 4, 5, or 6 here, for the thousandths place value, we might average the two numbers together. But if this is a 0, 1, 2, or 3, we'll probably go down. If it's a 7, 8, or 9, we're probably going to go up. If it's a 4, 5, or 6, we're probably going to average the two numbers together. All right. Z table time again. And we want between 3.01, 3.01 is 0.9987, and we're going to subtract negative 3.01, so that's going to be 0.0013. This is 4799, so 0.9974. We didn't talk about anything in this video about things that are bigger than 3.5 or smaller than negative 3.5. So I'll show you what to do with that with the table in just a second. This is one of the ones that is, make sure this wasn't the same thing. That was between. All right, so this is one of those doubling something. So we want these tails here, negative 2.25, positive 2.25. I'm going to look up negative 2.25 and double it. Negative 2.2, 0, 1, 2, 3, 4, 5, 0.0122. I know that this also has to be 0.0122. So this is 0.0244. Reason I know that has to be the same area to the right is the curve is symmetric about the mean of mu equals 0. All right, so key point here, your teacher is going to tell you exactly what to do here, but typically if we have numbers where we're trying to find the area to the left of negative 3.5 or something smaller, we're just going to say that it's 0 because there's practically nothing over there in that tail anymore. If we're looking for things that are to the left of positive 3.5 or greater, we're basically going to use 1 because essentially everything is to the left of there. There's a very, very, very small tail that's insignificant there. Some textbooks are going to tell you to use 0.9999 and 0, 0, 0, 1, but it's usually our teachers are going to tell you to use 1 and 0. If you want to know how much is to the right of a number that is less than negative 3.5, that's basically the whole curve to the right will be 1. And how much is to the right of a number greater than 3.5 or equal to 3.5 is basically 0. So you can be asked that question a couple of different ways. Just watch out for z values that are extreme like that and that are outside the range of negative 3.5 to 3.5, which are on your table. And make sure to follow the instructions that your teacher gives you for those. All right, that's it for this video, and we'll come back next time and we'll start talking about 5.2. See you for the next video.